Insert 6 numbers between 3 and 24 such that the resulting sequence is an arithmetic progression. So let the three terms of a geometrical progression or put it in order A by R, A and AR. The seventh term is equal to 64 means seventh term is AR to the power of 6 is equal to 64. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class, we have discussed regarding the problems based on arithmetic progressions and the geometrical progression. So today in this session, I will take few more problems on geometric progression and geometric series and also arithmetic and geometric mean. So let us discuss regarding the problems based on a geometric progression and a geometric series. Then I will go to arithmetic mean and a geometric mean. Now, first, the sum of first three terms of a geometric progression is 39 by 10 and their product is 1. Find the common ratio and the terms. So, we have discussed this type of problems in the last class itself. Let me take a similar type problem. The sum of first three terms of a GP is given. The sum of first three terms is 39 by 10 and their product, if you multiply, you will get it as 1. If such is the case, find the common ratio or and the terms. Now, just what is given? The first three terms, the sum of first three terms. Let the three terms of a GP be A by R, comma AR. Let us consider these are the three terms. What are the three terms? A by R and AR are the first three terms of a geometrical progression. Okay. Now, let us write in order. Let the three numbers be, write first A by R, A, then AR. What is given? Given that the sum of three numbers, sum is equal to 39 by 10. So sum means A by R plus A plus AR is equal to 39 by 10. Let us represent this as equation number 1. Now on the other hand, take the product of the terms. Product is given. What is the product? 1. So that means A by R into AR is equal to 1. This R and R gets cancelled. A cube is equal to 1. Therefore, A is equal to 1. So, A is equal to 1. Just substitute the value of A is equal to 1 in equation number 1. Put A is equal to 1 here. If you put A is equal to 1, 1 by R plus 1 into R is equal to 39 by 10. Take LCM and simplify, you will get a quadratic equation. Solve it, you will get the value of R. So, A is known and R is known. The three terms are A by R, A and AR. Very simple. So, let the three terms of a geometrical progression or put it in order A by R, A and AR. The sum is A by R plus A plus AR is equal to 39 by 10. Let us represent it as equation number 1. And the product, what is the product? Product is equal to A by R, comma A into AR is equal to 1. So, R gets cancelled, A cube is 1, therefore A is equal to 1. Put A is equal to 1 in this equation, 1 by R plus 1 plus R is equal to 39 by 10. So, therefore, this 1 by R plus 1 plus R is equal to 39 by 10. Now, just take LCM, here R is a LCM, 1 plus R square is equal to 39 by 10, cross multiply, 10 plus 10R plus 10R square is equal to 39R. So, put it in order, 10R square plus 10R minus 39R plus 10 is equal to 0. This is 10R square. 10 minus 39 is minus 29R plus 10 is equal to 0. Okay. Now, this is a quadratic equation. Factorize this, you will get the answer. Okay. So, solve this. This quadratic equation can be solved by any method, by factorization method or square method or by formula method or splitting the middle term. Let us split the middle term. 29 can be written as 10R square minus 25R minus 4R plus 10 is equal to 0. Now you can take the common factor. What is the common factor? So we can take a 5 is the common factor, 5r is the common factor, 5 2s are 10. So you will get 2r minus 5 5s are 25. Again you can take the common factor, 2 is the common factor. Then this is 2r minus into plus minus 2 5s are 10 is equal to 0. So therefore the factors are 2r minus 5 into 5r minus 2 is equal to 0. Substitute here. So that is 2r minus 5 is equal to 0, or 5r minus 2 is equal to 0. That means 2r is equal to 5, or r is equal to 5 by 2, or 5r is equal to 2, r is equal to 2 by 5. So the value of r is 2 by 5 or 5 by 2. Now two cases arises. When a is equal to 1, r is equal to 5 by 2, the three terms are what we have taken. So a by r, a and ar. A by r means 1 by 5 by 2 comma 1 into 5 by 2. So this is 2 by 5, 1 and 5 by 2, which is in a geometrical progression. Okay. On the other hand, so if we consider case 2, this is case 1. In case 2, so when a is equal to 1, r is equal to 2 by 5, the three numbers or the three terms are same. A by r, that is a by r, a and ar. A by r, 1 divided by 2 by 5, 1. A by r, a and ar, 1 into 2 by 5. So that's equal to 5 by 2 comma 1 comma 2 by 5. So here it is 2 by 5, 1 and 5 by 2. It is 5 by 2, 1 and 2 by 5 in the reverse order. That's all. These are the three terms of a GP whose sum is, what is the sum? 39 by 10, and the product is 1. See, if you multiply 5 by 2 into 1 into 2 by 5, 5 gets cancelled, 2 gets cancelled, 1 into 1 into 1 is 1. That's it. This is how we are going to solve this problem. Hope you followed. Okay. Very important for 5 marks. Now, let's take next problem. How many terms of the GP 3, 3 square, 3 cube, 3 to the power of 4, etc. are needed to give the sum as 120? So, we have to find n here. So, what is to find here is, n is the question mark, number of terms. So, what is the first term? First term is 3. And what is the common ratio? Second term by first term. 3 square by 3 is equal to 3. 3 cube by 3 square is 3. 3 raised to 4 by 3 cube is 3. So, just what is given? The nth term is given. Sn is given. Sum of n terms is given. That's equal to 120. We know the formula Sn is equal to, since r is greater than 1, we can take Sn equal to a into r raised to n minus 1 divided by r minus 1. 120 is equal to a, first term is 3, into r is 3 to the power of n minus 1 divided by 3 minus 1. So 120 is equal to 3 into 3 to the power of n minus 1 divided by 3 minus 1 is 2. Now cross multiply it. 120 into 2 is equal to 3 into 3 to the power of n minus 1. Okay. Now this can also be written as, I'll write here. See here, just since what is a is the second term divided by first, or third term divided by second term, any term by its previous term. So n, what is to determine? N, the value of n is to be determined. That is the number of terms. A is given, first term is 3, and the common ratio r is equal to 3 square by 3 is equal to 3, or 3 cube by 3 square is also equal to 3, and the sum of n terms is given. So Sn is equal to 120. Since r is greater than 1, therefore the formula we are going to use is Sn is equal to a into r to the power of n minus 1 by r minus 1. What is Sn? 120 is equal to 3 into 3 to the power of n minus 1 divided by 3 minus 1. So 120 is equal to 3 into 3 to the power of n minus 1 divided by 3 minus 1 is 2. Cross multiply. 120 into 2 is equal to 3 into 3 raised to n minus 1. So therefore 3 to the power of n minus 1 can also be written as 120 into 2 divided by 3. Bring this to the denominator. So this divide it. How many times? So this can be written as 3 4s are 40. So 3 to the power of n minus 1 is equal to 42 into 2 is 80. Or 3 power n is equal to 80 plus 1 is equal to 81. So 81 can also be written as 3 to the power of n is equal to 81 means 81 can also be written as 3 to the power of 4. 3 3s are 9, 9 3s are 27, 27 3s are 81. So whenever the bases are equal means the power is also equal to equal. So therefore n is equal to 4. So the number of terms, so how many terms are there means the number of terms is equal to 4. 4 terms are there in the series, so that the sum is equal to 120. That's it. Hope you followed. Okay. So what is the conclusion? Therefore, how many terms are needed means 4 terms. 4 terms are needed to get the sum as 120. That's it. Right. Now move on to the next problem. The sum of first 3 terms, that is A1, A2, A3. Sum of first 3 terms and the sum of the terms of a GP is 16. The sum of first 3 terms of a GP is 16 and the sum of next 3 terms is 128. Determine the first term and the common ratio and the sum of n terms of the GP. Now what is given here? First sum of first 3 terms is 16. So let the 3 terms be, let the first 3 terms is equal to A, AR and AR square. What is given? Sum. Sum is A plus AR plus AR square is equal to 16. Now let us represent this as equation number 1. Okay. Then next second condition. What is the next second condition? And the sum of next 3 terms. Next 3 terms are A4 plus A5 plus A6 is equal to 128. That is fourth term. First, second, third, fourth term is AR cube plus AR to the power of 4 plus AR raised to 5 are the next 3 terms. That's equal to 128. See, AR square, AR cube, AR raised to 4, AR raised to 5. The sum of first 3 terms is 16. Sum of the next 3 terms is 128. Let us take the common factor. What is the common factor? We can take so R cube is the common factor. Then we will have A plus AR plus AR square is equal to 128. So you can take AR cube as the common factor. Now substitute the value of A plus AR square. What is A plus AR square? From 1, this is 16. From equation number 1, R cube into 16 is equal to 128. That's it. See, A plus AR square is equal to 16 from equation number 1. So what is R cube then? R cube is equal to 128 divided by 16. Divide it. So divide it. R cube is equal to 128 by 16. That's equal to 8. R cube is equal to 8 means 8 can also be written as 2 cube. Therefore, the value of R is equal to 2. The common ratio is 2. When R is equal to 2, put R is equal to 2 in equation number 1. What is equation number 1? A plus AR square is equal to 16. A plus AR square is equal to 16. A plus A into R is 2 plus 2 square is 4 is equal to 16. 4 plus 2, 6 plus 1 is 7. A is equal to 16. A is equal to 16 by 7 is the first term. So the first term is 16 by 7 and the common ratio is 2. Now, so therefore, the first term A is equal to 16 by 7 and the common ratio is 2. So what is to find? So first term and the common ratio. This is the first term. So therefore, the first term is equal to 16 by 7 and the common ratio R is equal to 2. Now from this, what is to find? Determine the and sum of n terms of the GP. So Sn is equal to A into R raised to n minus 1 divided by R minus 1 because 2 is greater than 1, R is greater than 1. So Sn is equal to A 16 by 7 into R is 2 to the power of n minus 1 divided by 2 minus 1. So Sn is equal to 16 by 7 into 2 to the power of n minus 1 divided by 2 minus 1 is 1. That's equal to 16 by 7 into 2 to the power of n minus 1 is the nth term of the given geometric progression. Okay, that's it. Now, just move on to the next problem. Given in a GP with A is equal to 729 and 7th term is 64, determine S7. So, what is given? The first term is given with A 729. The 7th term is 64. Determine sum of the 7 terms. Now, what is given? Given that A, the first term 729 and the 7th term, yes, A7 is given, the 7th term A7 is equal to 64. What is to find is sum of A7 term, S7 is to be determined. Let R is the common ratio. Let R is the common ratio. Now, what is given? A7, the 7th term is equal to 64 means 7th term is R to the power of 6 is equal to 64. Now, just substitute what is A. We know A is equal to 729 into R power 6 is equal to 64. R to the power of 6 is equal to 64 divided by 729. So, R to the power of 6 is equal to 64 by 729. Therefore, this can be written as R to the power of 6 can be written as 64. 64 means 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64. So, that is nothing but 2 to the power of 6 divided by 3, 2 by 3 whole to the power of 6. Okay, right. So, just this is nothing but 64 by 729 can be written as 2 by 3 whole power 6. 2 power 6 is 64, 3 to the power of 6 is 729. So, therefore, the value of R is equal to 2 by 3. So, the first term is 729 and the common ratio is 2 by 3. So, the S7 is to be determined. So, sum of n terms Sn is equal to A into R to the power of 1 minus R raised to n divided by 1 minus R, because 2 by 3 R is less than 1. So, Sn is equal to S7 is equal to A. The first term is 729 into 1 minus what is R? 2 by 3 whole to the power of n divided by 1 minus 2 by 3. So, this is equal to n, just substitute the value of n as 7. So, S7 is equal to 729 into 1 minus 2 by 3 whole to the power of 7 divided by 3 ones are 3 minus 2 is 1 by 3. So, this can also be written as S7 is equal to 729 into, this goes to the numerator, 3 by 1 into 1 minus 2 by 3 whole to the power of 7. Okay, simplify this, that's all. So, if you want, you can write 729 into 3 into, just if you simplify, take LCM. So, that is 3 to the power of 7 minus 2 to the power of 7 divided by 3 to the power of 7. This is 729 into 1, 3 gets cancelled. 3 power 7 minus 2 power 7 divided by 3 to the power of 6. So, what is 3 to the power of 6? 3 power 6. So, 3 power 6 is 729. So, this is 729 into, so 3 power 7 is 729 into 3 minus 2 to the power of 7. 2 to the power of 6 is 64 into 2 divided by 3 power 6. This 2 gets cancels. Okay. Now, what is this equal to? This is equal to, simplify this. 729 to 3 is 2187 minus 64 into 2 is 128. 128. So, subtract this, 2059. So, therefore, the sum of 7 terms is equal to 2059. That's it, very simple. Okay. See here, just find out the value of R first. A is given, A is equal to 729 and the 7th term is given 64. That means AR power 6 is 64. A is 729 into R to the power of 6 is 64, means R to the power of 6 is 64 by 729 means 2 by 3 whole power 6. That is R is equal to 2 by 3. So, nth term, since R is less than 1, we can take a into 1 minus r raised to n by 1 minus r, 729 into 1 minus 2 by 3 whole to the power of n. Put n is equal to 7 divided by 1 minus 2 by 3 is 1 by 3. Take this to the numerator. 729 into 3 into 1 minus 2 by 3 whole power 7 is, so 2 power 7 by 3 power 7. This can be as take LCM 3 power 7 into 3 power 7 minus 2 power 7. So 1 gets cancelled in the denominator. 729 and 3 power 6 are nothing but 729 gets cancelled. So 729 into 3 is 2187, 2187 minus 64 into 2 is 128. 128. So if you subtract, you will get 2059. So sum of 7 terms is 2059. Right. Now move on to the next problem. Find a GP for which sum of first 2 terms is minus 4 and the 5th term is 4 times the 3rd term. So what is the given condition? So we have to find a geometrical progression for which sum of first 2 terms is minus 4 and the 5th term is 4 times the 3rd term. Let A is the first term, and R is the common ratio of a geometrical progression. Let A, AR square, AR cube, how many terms? AR to the power of 4, etc. is in a geometric progression. Now what is given? Given that first 2 terms means, yes, A plus AR is equal to minus 4. So you can take the common factor, A is out, 1 plus R is equal to minus 4. Let us represent this as equation number 1. Second condition. So the fifth term is 4 times the 3rd term. What is the 5th term? First, second, third, fourth. 5th term is AR to the power of 4 is equal to 4 times AR square. 4 times AR square. So transfer this side. So AR to the power of 4 minus 4AR square is equal to 0. You can take the common factor. AR square is the common factor. Then what we will get? R square minus 4 is equal to 0. So from this, AR square is equal to, if you divide therefore, from this we will get R square minus 4 is equal to 0. R square is equal to 4. R is equal to plus or minus 2. So R is equal to plus 2 or R is equal to minus 2. Two cases arises. So when R is equal to 2, find out the value of A. What is A? From this, from 1, A into 1 plus R is equal to minus 4. Substitute R is equal to 2. A into 1 plus 2 is equal to minus 4. Therefore, A is equal to minus 4 by 3. First term is minus 4 by 3. Okay. When A is equal to minus 4, R is equal to 2. The GP, required GP is AR square, AR cube, etc. A is minus 4 by 3. A minus 4 by 3 into R is 2. Minus 4 by 3 into R square, 2 square is 4. Into minus 4 by 3 into 2 cube, 2 2s are 4, 4 2s are 8. So this is nothing but, which implies minus 4 by 3, 4 2s are 8 by 3, 4 4s are 16 by 3, and 32 minus 32 by 3, etc. is the required geometrical progression. Okay. When R is equal to case 2, when R is equal to minus 2, substitute here. A into 1 plus R is equal to minus 4. A into R is minus 2. This is equal to 1 minus 2. 1 minus 2 is minus 1. So therefore minus and minus gets cancelled. A is equal to 4. So when A is equal to 4, R is equal to minus 2, then the geometrical progression is A. A is 4. AR square, 4 into R, AR square into AR cube. So this is 4 into 4 2s are 8 minus 8. Minus 2 square is 2 2s are 4, 4 4s are 16. So 4 minus 8, 16 when R is equal to minus 2 and A is equal to plus 4. This is the required geometrical progression. Okay, geometric progression. Now let us move on to the next problem. So insert 6 numbers between 3 and 24. Insert 6 numbers between 3 and 24 such that the resulting sequence is an arithmetic progression. Let us take A is equal to 3 and B, the last term, as 24. So in between 3 and 24, we have to insert how many numbers? 6 numbers. Let us call it as A1, A2, A3, A4, A5 and A6 are the 6 numbers. So therefore, what is n? The number of terms 6 plus 2 is 8 and A, the first term, is 3 and the common difference we don't know. The last term B is equal to 24. Now we know the formula for nth term. An is equal to A plus n minus 1 into D. That is 24. This is An. 24 is equal to A. A is 3 plus n is 8 minus 1 into D. 24 minus 3 is equal to 7D. So 21 is equal to 7D. Therefore, D is equal to 21 divided by 7, that is equal to 3. D is equal to 3. The common difference is 3. So first term is 3 and common difference is also 3. The terms, the remaining 6 terms are, if A is equal to 3 and common difference is equal to 3, the second term A1, A is the first term, the second term is A plus D, that is 3 plus 3, 3 plus 3 is 6. Next term A2 is equal to A plus 2D, that is nothing but 3 plus 6, that's equal to 9. Similarly, A3 is equal to A plus A2. A2 is 9, 9 plus 3 is 12. Similarly, the fourth term A4 is equal to A plus third term, that is, yes, A is 3 plus 12, that's equal to 15, and A5 is equal to A plus A4, that is 3 plus 15 is equal to 18, and the sixth A6 is equal to A plus A5, that is 3 plus 18, that's equal to 21. If you add 21 plus 3, you will get 24. That is the last terms. Therefore, the sixth terms, the six terms between 3 and 24 are, these are the 6 terms, 6, 9, 12, 15, 18 and 21. These are the 6 terms. So these are which are in arithmetic progression. That's it. This is how we are going to solve this problem. Okay, very simple for 3 marks. Hope you followed. That's it. This is how we are going to solve this problem. Very important problem for the point of examination. So that's all regarding today's session. Let us meet with different types of problems in the next session. Thank you. Thank you very much.